Alrighty folks, here we are with question number 2, and the learning targets for this one are the extreme values. Okay, so remember extreme values, this means the high and low point of a function. Okay, so number 2 says, if for all x, f prime of x is equal to the quantity of x minus 2 to the fourth times the quantity of x minus 1 cubed, it follows that the function f, and it basically gives you a bunch of choice for the extrema, or the high and the low point. So for this one, we're going to employ we're going to use the first derivative test. So if you remember the first derivative test, what it basically says is where f prime of x equals 0 or f prime of x does not exist is a critical number, and then you want to make a sign chart, or basically test a number line slash like a number line, and test about the critical numbers. Okay, so that's basically what we're going to do for this problem. So in this case, it's actually pretty good because they already gave us the derivative here. So all we have to do is find where the derivative is 0. All right, and if you look at it here, there's no value for which the derivative is undefined here because there's no radicals or rationals or anything. That's typically what we have to worry about for this part here. So we don't have to worry about this. Basically just need to worry about where f prime is 0. So we're going to set f prime equal to 0. So f prime of x is equal to, what was it, x minus 2, right? X minus 2 to the fourth, times x minus 1 cubed. And we're going to set this to 0. So the roots to this one are going to be when x minus 2 to the fourth is 0, and where x minus 1 cubed is 0. The cool thing about when you have a factor like this raised to a power, you can just take the root of it. So if I take the fourth root of both sides, and here if I take the cube root of 0, it's always going to be 0. So these cancel out. X minus 2 is 0, so x is 2, and the cube root and the cube go away. The cube root of 0 is 0, so x minus 1 is 0, so x is 1. So these are my critical values. So now we're going to make our chart. Notice all I found here are where f prime is 0. So these values here are going to be my my important points, or my critical points. That's why they're called critical, because they're important. And we're going to see if those are extreme values or not. So notice over here here's 1 here and here's 2. I like to put these like this, kind of like, think of these as our barriers, right? Now we're going to test around them. And notice it's called the first derivative test because you're going to pick values here and plug them into the first derivative. That's why you're going to test them. So let's go ahead and pick some. You always want to pick easy ones. We're going to pick 0, 1.5, and maybe like, I don't know, like 10 or something. I mean, it doesn't matter, but I'm just picking whatever. And I'm going to plug them into the derivative here. So if I plug 0 here, so notice I'm just plugging them into f prime, and I don't care about the answer. I'm just going to look for the sign. The sign is if it's positive or negative. So this is negative 2 to the fourth is positive here, and then negative 1 cubed is going to be negative. Positive times a negative is a negative. So this one is negative, which means the function is decreasing until 1. Now, that doesn't imply it's increasing. We have to check between here. We're going to plug it again into the derivative. So I'm going to get, I'm plugging in 1.5 in for x here. Okay. So what we get is, it's going to be 1.5 minus 2 to the fourth times 1.5 minus 1 cubed. Now, anything to an even power is always positive, so this doesn't matter, it's just positive, right? And then here, 1.5 minus 1 is going to be positive 0.5. over here, right? So if I get positive 0.5, that means it's positive times a positive is a positive. So this means this actually starts to increase here. And now we're going to see what happens at 2 here. So we're just going to plug this 10 in, just for fun. Remember, it doesn't matter which one you use. You're going to plug it in. So if I get 10 minus 2 to the 4th times 10 minus 1 cubed. So this gives me a positive, right, no matter what. And this one here, 10 minus 1 is 9. 9 cubed is positive, so it just gives me a positive. So basically, this function looks like this, which means it has a minimum. So this means it has a min. Let me write this here. Minimum at x equals 1. Okay, so we don't know what the minimum is. We just know it happens at x equals 1. To find that, we would have to plug x into the original. We don't have that. All we have is f prime. So we really can't do that. So all we know is there's a min at 1. So now we answer the question here. And it says it's a relative min at x equals 1, it should say here. Okay, so then the answer is going to be A.